All right, so today we are going to talk about part 2 of the development of the atomic theory, and that is the atomic structure. So, parts of an atom, we have an atom, which is the smallest unit of an element that retains the properties of that element. And it is comprised of two regions, the nucleus, which contains protons and neutrons, and the electron cloud, which contains electrons and empty space. There are three subatomic particles within an atom. We have a proton that is positively charged and weighs about 1 atomic mass unit and is located inside a nucleus. And then if we change the number of subatomic particles, so if we change the number of protons, we'll end up changing the element. So the number of protons never actually change. Neutrons have no charge, so they are neutral. They weigh about 1 atomic mass unit, and they're located inside the nucleus. If we change the number of neutrons an atom has, we end up changing the isotope, which results in the change in the atomic mass. An electron is a negatively charged particle that has 1 in 1840th atomic mass unit. It's located inside the electron cloud, and if we change the number of electrons, it becomes an ion, resulting in a charged particle. All right, so now we have atomic number. An atomic number is the number of protons in an atom, which determines the identity of the element. And the modern periodic table is arranged by atomic number. So we start with hydrogen with 1 proton, or the atomic number 1, and it has 1 proton. Then we move to helium, who has 2 protons and the atomic number 2, and then lithium, who has 3 protons and the atomic number 3. All atoms containing 6 protons are carbon atoms, just like all atoms that have 1 proton are hydrogen atoms, and 2 protons are helium atoms, and 3 protons are lithium atoms, and so on and so forth. So in our periodic table of elements, we can see, right, the atomic number at the top. So if I have my periodic table, I have my carbon block, my top number is going to be my atomic number. And then I'm going to, right here, have my element symbol. You cannot see that. Let's see if light. There we go. Okay, I guess I have to write with my mouse. And then down here, we have our atomic mass unit, or our average atomic mass. And each one of our elements is going to have these numbers displayed. So it's going to have the atomic number, the element symbol, and the atomic mass. Isotopes are elements of the same, or atoms of the same element with different numbers of neutrons. So we can see up at the top, we have a great example. We have hydrogen 1 that just has 1 proton and no neutrons. Then we have hydrogen 2, which is 1 proton, 1 neutron, and then hydrogen 3, which is 1 proton and 2 neutrons. The name of the element, so hydrogen, is then followed by the mass number, and that identifies what isotope you have. So hydrogen-1 means you have a mass number of 1 and that you have 1 proton. Mass number is the sum of the number of neutrons and the number of protons in an isotope. Mass number equals protons plus neutrons, right? So if I have a carbon 12, I'm going to have 6 protons because we know carbon has 6 protons. I take 12 and I subtract it from 6 and I end up with 6 neutrons. Then we have isotopic notation, and this is when we write the mass number in the superscript, so really tiny up at the top of the element symbol. And then we have the atomic number, which is written in the subscript. So we write it really tiny at the bottom of the element symbol. So you can see this in the example below. We have 17 oxygen. So you can see, I'm sorry, that oxygen 17, the mass number is written at the top, or the superscript, and then our number, or our atomic number, is written down at the bottom, so 8 is our subscript. And to figure out how many neutrons I'm going to have, I'm going to take 17 and subtract it from 8, which gets me 9 neutrons. Then, now that we've talked about what isotopes are, let's talk about what ions are, right? So one, we're changing the neutrons, and now we're going to change the electrons. So when an atom has an equal number of protons and electrons, it's electrically neutral. So it's like subtracting 8 from 8. We're going to get 0, so there's 0 charge. A positive charge exists on the proton, and a negative charge exists on the electron, and they cancel each other out. But if we have more protons than electrons, or more electrons than protons, we're going to get different ions. And ions are atoms that have unequal number of protons and electrons. Thus, an ion can either be positive or negative. So we have cations, and they are positively charged, which means they have lost an electron. So if you have a cation, so let's say hydrogen plus, I'm going to subtract an electron. I know it makes a little controversial, or like a little, not a lot of sense. So hydrogen has traditionally 1 electron. I'm going to subtract that electron, so it has no electrons, meaning it has 1 positive charge. I like to remember what cations are, because cats are positive, P-A-W, positive, ha ha ha, funny joke. I also like to make the joke that cats are the most positive animals on the planet, so they are positively charged. Anions is a negatively charged element or ion, and that means it has gained an electron. So if I have hydrogen with a little negative sign at the top, that means we have added an electron. That means it has 2 electrons and 1 proton, making it negatively charged. So here are some examples. Hydrogen plus, is that a cation or an anion? It's a cation because it's positively charged. CO3 2 minus, is that a cation or an anion? It's an anion because it's negatively charged. Sr2 plus, is that a cation or an anion? It's a cation because it's positively charged. And then Cn minus is a cation or an anion? It's an anion because it's negatively charged. So now that we've talked about isotopes and ions, we want to talk about mass number and atomic mass. So mass number is the mass that describes a specific isotope of an element. So carbon 14 is going to be that mass number. We saw that with the oxygen 17 example a couple of slides back. That 17 is that mass number. It tells you how much mass that atom has. So we know that carbon has 6 atoms. If my mass number is 14, I'm going to take 14 and subtract it by 6, which means I have 8 neutrons. Atomic mass is the weighted average mass of the isotope of an element. So helium has 2 protons and 2 neutrons on average. Our atomic mass is typically about 4.02, and that's where we take all of the isotopes that are found in nature and then figure out how abundant they are, and then do some math and get the average of all of those isotopes. Our atomic mass is typically around the most abundant, but not always. So we can calculate subatomic particles, and here's a little example. So we have lithium with a mass number of 7 and the atomic number of 3. So we know that our atomic number equals the number of protons. So we have 3 our atomic number is 3, so that means we have 3 protons. And our neutrons are 7 minus 3, right? Because we take mass number and subtract the number of protons to get neutrons. And that means we have 4 neutrons. And we know that lithium doesn't have a charge on it. So electrically neutral atoms, electrons are equal to protons. So we have 3 protons. That means since it's electrically neutral and I haven't indicated that it's a positive or a negative, we are going to have 3 electrons. Neon has a mass number of 20 and an atomic number of 10. Protons, right? We have 10 protons because protons equal our atomic number. And then neutrons, right, are mass number minus atomic number. So 20 minus 10 equals 10. Since I haven't indicated that neon is positive or negative, we know electrons equal protons, and that means we have 10 electrons. All right, so now we are going to move on to the average atomic mass, and we're going to do some calculations to figure out what these are. Average atomic mass is the weighted average of an element's isotope and the mass found and is the mass found on the periodic table. So, right, we looked at the carbon atom, had 6, it had the C, the element symbol, and then it had 12.011, and that is our average atomic mass. So, the average atomic mass will typically fall between the mass of the heaviest and the mass of the lightest isotope. And like I said before, it generally is closest to the most abundant isotope. To find the atomic mass, you need 2 pieces of information. The mass number of the different isotopes, not the average mass found on the periodic table, but the mass number, so that 14, carbon 14, that 14, or that oxygen 17 that we've talked about before, and then the relative abundance. So what is the percent composition of all of the different isotopes in your solution? So isotope composition is the relative amounts of each isotope of an element found in a sample. And then we can take the isotope composition and find percent abundance. So this is the percentage that describes that composition. So here we can see 35 chlorine has about a 76% composition in the sample, and then we can see 37 chlorine has about a 24% composition in the sample. So that is our percent abundance. So we can find the average atomic mass by taking the sum of all of the different isotopes, mass times the abundance. And we can do this in 3 steps. First, we need to change the given percent abundance to a decimal form, and we'll do this by dividing by 100. Then we multiply the given mass for each isotope by the percent abundance in decimal form. So what we find in step 1, we will then find in the abundance in, then we will multiply the abundance, what we found in step 1, by the mass. And then finally, we're going to add them all together. So find the sum of all of our products. So let's work an example together. Even though it is less massive, neon 20 accounts for the vast majority of neon. So let's figure out our average mass, atomic mass. So the first thing we're going to do is convert our percent abundance to a decimal place, and we're going to divide them by 100. I know the answers, so I'm going to write them. So this is 0.906. This is 0.002. And this is 0.09. 2. So now that I have my abundance into decimal form, I know it's hard to kind of see, I'm going to take that and multiply it by my mass. So 20 times 0.906 is going to be 18.2. And then 21 times 0.002 is going to be 0.04. Ooh, that's a bad 2. Sorry. And then finally, neon 22 is 22 times 0.092, and that is going to be 2.024. So now that I have figured out my mass contribution, I'm going to add them all together, and I'm going to end up with approximately 20.02. Let me rewrite that too, because that looks horrible. 27 AMU. So now that I've looked at this, let's do a couple of other examples together.